All right, we're getting started with a new topic that you've seen before in algebra. It's systems. So what that means is you have two or more equations, and you're trying to figure out either one point or maybe a set of points that satisfy both equations at the same time. And first, we're going to start by graphing. This is the most direct way to do it, and with technology, it's made a lot easier. So again, a system of equations is a set of two or more equations. So for example, just any two equations like this, and typically we pick x and y. Those together, I put that little curly brace just to show that that is the system. You'll see that sometimes you won't, but they're grouping those two equations together. So a solution, again, is a pair, an xy pair, that makes each equation true. So for example here, if we pick 5 for x and 1 for y, we satisfy both equations with that point, right? Because the top one would be 5 plus 1, and the bottom one would be 50 plus 1. So that is the solution to that system of equations, okay? So if it asks you to check if a solution is truly a solution, all you need to do is just plug in to each of the equations what x is and what y is. And if you just simplify both of those equations, it looks like this one is completely true. And if you ask me, this next one looks completely true also. So that point is a solution to those two simultaneous equations, okay? Same deal here. I'll go ahead and plug in -2 and 1. And same deal here. So plug in -2 and plug in 1. Okay, so right off the bat, though, I know that minus times a minus is a plus, and I get a scenario where this doesn't really make sense. So no. Right off the bat, I can stop. I don't even care what the top one's equal to. It didn't work for the second equation, so it's not a solution to both. Okay? Now, graphing. We spent all this time in chapter 4 talking about how to graph a line. Well, let's recall what that looks like and how we do that. So B is the y-intercept, and slope is the direction of where we go. 3 over 1 means up 3 over 1. So drawing it the best I can, so we can only do so great by hand, and we're not always going to do these by hand, which is kind of nice. Anyhow, let's graph this one too. So I'm going to divide everything by 2. You want to solve for y, and then I can see what my slope is and what my y-intercept is. So I'll start at 5. Remember, the 5 is a y value. You start in the vertical, you don't start here. Don't start there. So down 1 over 2, down 1 over 2, down 1 over 2, and I'll just complete this line the best I can, and there we go. So what do these graphs really represent? A line is really a set of points. So this line in this new notation and vocabulary that we have, it's a set of all points that make our equation true. So they are the solutions to y equals 3x minus 2. For example, like this point here, 1 comma 1. You put a 1 in here and a 1 in here, you get equal on both sides, right? So basically a line is just the set of all of the points that make the equation true. And to be honest with you, the answer to this one is just the same thing, except now we have a different equation. Okay? So now it's asking, okay, what if we consider both of these together at the same time? So just for the sake of showing this, I'm going to go ahead and make a blue copy, and I'm going to overlay it on the same graph. Okay? So it's asking, what would the solution to a system look like? And again, remember, the system has a solution if it satisfies both. Or in other words, is it on both lines? And yeah, this is definitely on both lines. Right here at that intersection, it looks like 2, 4 is the answer. In other words, x equals 2 and y equals 4. Because that's the intersection. So whenever we have intersecting lines, the intersection point is the solution. Okay, so to find a solution, go ahead and just graph both of them, and then find the intersection. Okay, so yeah, it is a little bit of work to do this, I think, by hand, but let's go through it here with you, and I'll let you do the second one on your own. So first of all, I want to get, so these are grouped, I want to solve each of them for y. You don't always have to do that, but sometimes I think it's a little easier if we just go ahead, because I want to try and graph them with mx plus b like I just did, so it's probably a good idea that I solve for y. Okay. Let's go ahead and go with -4. All right, so I'm going to go ahead and call this one our green one. And I want to go down to -4 and follow the directions for slope. Down 1, over 2. Down 1, over 2. And I want to do the same on this side, just following that line, that stair-step pattern all the way across. Okay. Now, the blue line will be this guy. So I'm going to start at +4. And I'm going to go up 3. So 1, 2, 3. Going 1 above is fine. And then over 2. So it looks like, and then if I want to go the other way, I need to go down 3 and over 2 this way. So down 3, over 2 this way. Hold on, let me make sure oh, it should be right here. Okay. So being really careful, counting the boxes. Remember, it's rise over run. But with our nice graph that we made here, I'm pretty certain that the solution is right where those intersect. Okay. And because I counted the boxes, both of them landed directly on that grid point there. Okay. For this line, I want to go ahead and use point slope form, which looks like this is the point 3, 1, where m is 2. So that's how I'm going to graph this guy. So it's up 2 over 1. And then, of course, I want to go backwards as well, just to get the best picture I can. So it's very precise. We have to be precise with this. I'm going to multiply both sides by 2. And I'm going to move the x over. And then I'm going to divide by -1. So this will be my green line. And I'll just go ahead and go -2 and then up 1 over 1. The slope is 1 over 1. So it is just a nice up 1 over 1, up 1 over 1, up 1 over 1. And once I get my intersection, I can kind of just stop and just sketch the rest. Again, I'm really searching for where they intersect. So the point 3,1, if you plug this into those equations, it'll work for both of them. That's what the solution means. Okay? Let's graph a few special cases here. I guess I didn't give you time to solve that one on your own. Let's actually, you guys try that now. Go ahead and pause the video and try and graph these two lines for me. Okay? Okay. So first equation looks great. Next equation needs to be divided by -2. Okay, make sure you see those steps and how that works out. All three of those terms, one, okay, come on. 1, 2, 3 of those all are divided by -2. So I noticed something a little weird. These equations look pretty simple, right? They both are really similar. They both have the same slope. So this is what we mean by a special case. So this line, the green one, starts at 6 and then just has this very up 1 over 1. You know, it hits every grid nicely like this. And then the same thing happens for this blue one, except it just starts down here at -2. Okay? So up 1 over 1, up 1 over 1, up 1 over 1. We kind of get the conclusion that, hey, these lines are never going to touch. I can never pick a point that has both of these lines included on it, right? So this is what we call there's no solution because there is no intersection. Okay? And this next one is even weirder, I think, because this equation, if we divide everything by 4 and we solve for y, look at that. We get the same exact equation. The same one, same exact equation. So basically, if we sketch this, so going down 1 over 1, and then if I were to graph it again, I would graph it right on top of itself. So that means there's infinitely many intersection points. Everywhere you look on the line, it intersects with itself. So this is where we say infinitely many solutions. Okay? So those are your two special cases. So it boils down to this summary. System doesn't always have to have one intersection point, one solution. It can have 0 solutions or infinitely many. So there you have a nice little diagram for you there to remind you that this has one solution, this has 0 solutions, and this has infinitely many solutions. Okay? And even nice there, they made that graph purple because those two lines are directly on top of each other, which would mix to make it purple. Okay? Now, graphing with Desmos, our savior, right? Going through and graphing these one by one is a lot of work. But with Desmos, we can find out the answers to these systems of equations really fast. I mean, Desmos is a graphing calculator. It should be good at this. Okay? So all you have to do for these 4, I'm actually not going to do all of them for you. I'm just going to do these 2. You can try those other 2. I'll give you these solutions. This is infinitely many. You can look at the key, or you can graph those for yourself on Desmos if you'd like. I just want to show you how to do it. So for this first one, I'm going to go ahead on Desmos. You can use it on an iPad if you want, or your phone. But I'd recommend using your Chromebook because you'll probably have your Chromebook with you on the test. So there was one of them, and I'm just typing. I don't have to solve for anything. Don't divide by 4 or anything crazy. All you do is you just type it in as is, and not only does it graph it for you, but it already tells me what I don't know if you guys saw that. I kind of made it go away, but it had that point, there it is, that gray point ready for me, and it just gives me the answer. Okay, so the answer to this is this and this, but you need to recognize that that really means that this is this and this is this, right? It's a point. It's the point of intersection, but it's also equal to x and y. You know, what X and Y need to be. So make sure you recognize that. Easy enough, right? Let's try it one more time with these, and then I'll talk about those last couple blurbs. This one was y equals 1/2 of x plus 2. And this other one was 8y equals 4x minus 40. All right, so my graph is really not in the right place right now, but that's fine. I can just go ahead and draw my finger and try and find the lines. I see it's minus 40, which kind of looks like it might be pretty far down there. But look, there we have it. These lines here don't look like they touch anywhere. So if we have a system and we're trying to say, hey, what x, y point, what do you pick for those two things to make both equations true? It's not possible because there's not a point that lies on both lines. You only can get one, you can't get both. So parallel lines like this, that's where we have no solution. So it isn't enough to just say, oh, they're parallel. You have to say that there is no xy point that makes this true. There are no intersections. Okay? And just as a real thing, just to look and kind of recognize some things, if you look at a system and it has the same slope and a different y-intercept, those are going to be parallel lines, right? Because they have the same slope, just like the graph we just did, right? They have the same slope, but they hit the y-axis at different spots, so they just kind of never touch. So noticing that from a system, if you have the same slope, different y-intercept, those are going to be parallel. All right, and the same thing actually happens with these equations too. See how there's 3 different sets here, but they all actually are kind of the same form. They both have a slope of 3 here, yet they start at a different point, right? So you can imagine that would be like having a point here and then having a slope of 3, but then having a point over here and then a slope of 3. Those are also parallel lines, yeah? And then if you did some work with this one, I bet you could see that they have the same slope. They look really similar, but it seems like that constant term is a little off. So these all have no solution, okay? So parallel lines means no solution. That's a big connection. These ones are even, they're kind of silly. They don't really make sense. Like, why would you put the same line in a system with itself? But it turns out because they are the same, they overlap everywhere. And that's why we have infinitely many. And if you did the math, you could see with all those other systems, they in fact are just the same equation. Okay. All right, and I left some instructions here. If you want to use the TI-84 to graph, be my guest, please. You'll have that maybe next year to use. But Desmos is going to be our primary tool since you can use that for testing here in high school. So, okay, thank you.